Pretty input vectors question here. So a gas company maintains a straight pipeline that passes under a mountain. Pipeline's modeled as a straight line, and one side of the mountain is modeled as a plane. There are access ways from a control center to two access points on the pipeline. So the first thing I tried to do in this question is get a little sketch down. I drew a mountain, and then I drew one side being modeled as a plane. And then it says the pipeline passes underneath the mountain, so I just drew it sort of straight underneath like this. Now it doesn't say a lot, but it's the access ways from a control center to two access points on the pipeline. Modeling the control center as the origin, the two access points have coordinates P and Q. So I kind of just said, right, this is the origin, this is our access way. Or was it, sorry, the control panel. And then this can be P and this can be Q. Of course, we're working in 3 dimensions here. So we can draw vectors from the origin to each of these points. And we've got the coordinates, and then we're asked to find a vector equation for the line PQ in vector, like in parametric form. Okay, so to do this, we can use one of the vectors to get onto the line. Okay, so I can either use P or Q, and then we can find the vector, the direction vector. So in fact, I'm going to do it on my diagram below. Just going to bring these down. So these are coordinates, but we can turn them into position vectors. Okay, so then PQ is going to be OQ minus OP. So it would be 300, 300 minus 50, minus 300, 400 minus 150. And that gives 600 minus 100 and 100. Now you can use it as your direction vector, but I decided to factorize out 100, just to keep it as simple as possible, really. So 100 times 6 minus 1, 1. In fact, that is what I'm going to use as my direction vector. I'm going to ignore the 100. So this is all part A. So then R is going to be, I can either use OP or OQ here. So I decided to use Q. The numbers were marginally nicer. So R is then going to be 300, 300 minus 50. Get onto the line. Plus some scalar multiple of this direction vector, 6 minus 1, 1. If you kept the 600 minus 100, 100 is absolutely fine. You might just find that some of your working is going to be different than mine, but you should essentially get, well, you should get the same answers for the vital, the vital things that were asked for. Right, let's take a look at part B. We're now told that the equation of the plane is modeling the side of the mountain is given by the equation shown. And the company wants to create a new access way from this side of the mountain to the pipeline. The access way will consist of a tunnel of shortest possible length between the pipeline and the point M 100, K 100 on this side of the mountain where K is a constant. Using the model, find the coordinates of the point at which this tunnel will meet the pipeline. Okay, so what we first of all need to do is work out the value of K. But remember, we know that this is actually on the mountain, so I can sub in to here. So it must be that 200 plus 3K minus 500 is equal to 300. That means that 3K is going to be 600, K is going to be 200. So I've got this point on my mountain somewhere, like here, for example. This is going to be M. And then I want to investigate where it's going to meet the pipeline. Now, because we're looking for the tunnel of shortest distance, like whenever you have, if I just draw away, if you've got a point here, let's move away from the world of 3D vectors, but we've just got a point in two-dimensional space and a straight horizontal line, then to get there in the shortest possible length, we're just going to go straight down at a right angle. If the line was sort of, at an angle or something, then it would still be, it wouldn't go straight down anymore, but it would still be at a right angle. And that's what's going to be happening here. So because I've drawn my pipeline horizontally, I'm going to draw a line straight down. Of course, we don't really know, we just know it goes under. But the point is, it's going to be at a right angle. That's going to be crucial. So I'm going to then say it meets at a point x, which I'm going to say is x, y, z. So we have m. Oh, really right. 300 then. So m is 100, 200, 100. Okay. And I know that this is perpendicular to the line. So I'm going to find the vector mx now. So this is B part 1 continued. Before I carry on, I just want to backtrack and just make sure you're happy with everything. So look, we found the I mean, it's pretty standard finding the vector equation of the line. You get onto the line, use a direction vector. You're right, I just happen to simplify it and write it as 6 minus 1, 1 as my direction vector. All good there, I hope. I've drawn a diagram, and I do think this is quite complicated to get your head around, but I don't, at the end of the day, I was trying to like draw it accurately, and it doesn't really matter. Key thing is that you just have a plane for the mountain and you have some sort of line, which I've put underground here. So we're then trying to get, well, we've worked out the coordinates of m using the vector equation, and we'll come back to that. But now we're trying to get the shortest length from m to the line. So I've said, right, we're going to go at 90 degrees to the line. That's going to be that's going to give us the shortest length. And I've constructed the point x. So now we want to work out mx. So that's going to be x, y, z minus 100, 200, 100. But remember, x is on the line, and so we can work out um, OX, which is the XYZ, using our vector equation from part A. So therefore, mx is also going to equal 300, 300 minus 50, plus lambda 6 minus 1, 1. I've just replaced XYZ here by this, then minus 100, 200, 100. So I'm getting the vector equation of this line. And I'm going to have 200, 100 minus 150. Then plus lambda 6 minus 1, 1. Okay, so, but now, because I know that mx is perpendicular to the line, the shortest distance, it must be that mx dot producted with the direction vector of the line is 0. So 200 plus 6 lambda, 100 minus lambda, minus 150 plus lambda, dotted with 6 minus 1, 1 is equal to 0. This gives us 1200 plus 36 lambda minus 100 plus lambda minus 150 plus lambda is equal to 0. So then 38 lambda ends up equaling minus 950, which looks really awkward, but actually it turns out that lambda then is equal to minus 25. And we can sub that back in. So for OX, well, we can sub it back into this equation from A. So we get 300 minus 50. Then plus 25, 6 minus 1, 1. 6 minus 1, 1. Sorry, it was a minus 25. Which gives, oh, I'm writing it as a matrix, which gives 150, 325, and minus 75. So then the coordinates, we were asked for, I think you get away with that, but the coordinates would be 150, 325, and minus 75. We're also asked to find the length of the tunnel. So for this, I need to get back to mx and sub in 25, which is going to give me minus, so remember it was 25, so I'm going to minus 25. It's going to be minus 50, 125, and minus 175. Then mx, you can just use 3D Pythagoras. We just do 50 squared plus 100. You can ignore the negatives, plus 125 squared plus 175 squared, square rooted, which gives 220.794, or 221 meters. Then told it's only practical to construct the new accessway if it will be significantly shorter than both the existing accessways OP and OQ. Determine whether the company should build the new accessway. So we need to work out each of these lengths. OP would be, well, it's going to be 300 squared plus 400 squared plus 150 squared, all square rooted. That ends up being 522. So it is significantly shorter of that one. Then OQ, along similar lines, 300 squared plus 300 squared plus minus 50 all squared, square rooted, ends up being 427. So new tunnel, much shorter. So company should build it, should build new accessway. I was meant to say new. Then suggest one limitation of the model. Throughout the whole thing, we've assumed that the pipeline was a straight line. Now, that's not a bad model, to be fair. It's probably, you're going to try and make it a straight line if you can. So I don't think that one is massively flawed, but it's the side of the mountain. The mountain's not going to be perfectly smooth. So that's what I would go with here. Side of mountain, likely to not be flat. Some other things you could say that the tunnel and or pipeline will not have negligible thickness, which is what we assume, so modeling as lines may not be appropriate, and the shortest length tunnel may not be possible or most practical as the strata of the rock in the mountain have not been considered by the model. Okay, those are kind of next level kind of ideas here. I'd say this is just a good one to go with, but it's good to think about multiple options, so that's why I've put them up here. Okay, very well done with this question.